Hello class, today we're beginning chapter 6 and we're going to be covering equations in two variables. We're on lesson number 1 with the same name, equation in two variables. It's an introductory lesson. We'll be introducing the variable y. We've been using the x. And to begin, let's go to the illustration, the Peanuts cartoon at the top. And one of the characters says, "I'll never get the second problem." And that's Franklin, and Peppermint Patty answers, "Just put down 11, Franklin, and don't worry about it. That's what I did." And then he also says, "X is almost always 11, and Y is almost always 9. And he says, "One thing I've learned about algebra, don't take it too seriously." Well, I don't know if I'd say don't take it too seriously right now, considering it's going to be a very integral part of your math experience. And of course, this is comedy. And but notice that Peppermint Patty's saying x is almost always 11 and y is almost always 9. We never know what x and y is going to be until we actually solve the problem. And there's really never any probability that x or y would be any particular value. But let's read on. So far, the equations that you have learned to solve have contained only one variable. However, many practical problems in algebra require solving equations having two variables or even more. Here's an example of such an equation. We have 3x minus 2y is equal to 15. Now, let's see. Let's put that up here on the board. Let me get my pen, and we'll get moving along here. And let's see, it's 3x minus 2y, and that's supposed to be equal to 15. Now, as we see here, to solve this equation, we have to find numbers that can replace x and y to make this equation true. The numbers named in the cartoon will work, because when you do the multiplication here, you'll see if x is 11 and y is 9, well, is it true? What does that equal? Well, it equals to 33 minus 18. Okay, and that is actually equal to 15. Actually, there should be a 15 up here if we're just carrying down our equation. Now, just because it works here doesn't mean it's going to work for everyone. But it's just they use this as the example of using the x value as 11 and y as 9. Now, a simple way of writing the solution would be x is equal to 11 and y is equal to 9. And you can also write them as coordinates. Okay, we can write them as the coordinates as you've learned earlier. Remember, x comma y, and the x goes first, so we would write this as 11 comma 9. Now, knowing this, you know that you can plot this on an axis, okay, on a graph. It is easy to find more pairs of numbers that are solutions of the equation. For example, if x is equal to 1, and you see we do the math here, we're just going to plug in the next value for 1. And that means we'll have 3 times 1 minus 2y is equal to 15. That means 3 minus 2y, because you multiply 3 times 1, and you get 3. And you have 3y minus 2y is equal to 15. Now, we're going to want to solve this equation. And if you remember well, we could subtract the 3 from each side, which is basically what they did here. They also created this little plus minus 2y or plus negative 2y. It's just sort of a way to note that when you remove that 3 from one side, you really have a negative 2y that's left behind. Okay, so don't get confused with that. So it leaves us with negative 2y is equal to 12, and when we divide both sides by negative 2, it will end up with y is equal to negative 6. So if we plug that back in at the top of page 241 and checking x equal 1 and y is equal to negative 6, we're going to see that it does equal to 15. So another solution is 1, negative 6. So let's put that over here as well. 1 and negative 6. So it would look something like that. It is possible, in fact, to replace x with any number and find a number for y that will make this equation true. This means that the equation has an unlimited number of solutions. Some more solutions are 5, 0, 6, 1.5, and -3, -12. Equations that contain more than one variable usually have an unlimited number of solutions. Now, if we restrict the solutions to certain types of numbers, however, their number may be limited. For example, the only pairs of positive integers that can replace x and y, okay, and make the equation x plus y equals 4 true are 1 and 3. So we're only allowed to use positive integers, okay? So it would be 1 and 3, 2 and 2, and 3 and 1. If you're able to use negative, then you really use you'll end up with an unlimited number, but we're restricted only to positive numbers. So now we have a finite number of answers. Notice that the order in which we name the pair is significant. 1, 3 means x is equal to 1 and y is equal to 3, whereas 3, 1 means that x is equal to 3 and y is equal to 1. Because of this, the solutions to an equation having two variables are called ordered pairs. So remember, you always put the x first when you're given your answer. There's your example. And again, it could, as the example showed here, we had 1, 3. It's completely different than from 3, 1, because 3 would be, in the second case, 3 would be the x value. In the first case, 1 would be the x value. So be very, very careful with that. And we'll move on to our exercises next.